This video is brought to you by Sporlan, quality, integrity, and tradition.
We have a air conditioner here that the customer's complaining is not working. This air conditioner feeds a section of their dining room, and they said over the weekend it was nice and hot. Let's open this up. Okay, so right off the bat, we have an error code 32. Error code 32. Freeze stat number 1 is open. Look at compressor number 1. Compressor number 1, the suction line is ice cold coming to the compressor. The whole compressor body is frosty. This compressor is all frosty. Something's going on here. So, looks like we've got 1, 2, but not this contactor. I think this is the indoor blower motor. Okay. We've got condenser fan motors running. One of them is running. This one is running, that one is not. Let's have a look over here at the air filters. So the air filters run this section right here. Oh, this whole, look at all the, this whole section is frosted up. And I don't know if you guys can see in there, that indoor blower motor is not running. Okay, so we need to dig into that. Why is it that we have no airflow? This guy's going off on freeze stat and probably low pressure. Let's open this up. Look at that. Belt's broken off. Is it as simple as a broken belt, or do we have more problems than that? We can go ahead and shut this guy off. This just went off on 24, which should be a low pressure.
Low pressure 2.
Low pressure 2 just opened up. This guy's clearly running, but it has no belt on it. I can see the belt back there. So we're gonna get that belt out and investigate it. Why did it throw the belt? We investigate this guy and look at this. Look at this belt. That thing was a problem. What's the overall condition of the belt otherwise? Look at the sidewalls. It's an old belt. You can see that there's cracking in between. So this belt definitely was worn out. Luckily, we've got a brand new spare in there. So we're gonna get that put on, and then we're gonna evaluate the condition of the pulleys, because if the pulleys are bad, it can cause the belt to get stuck. There is some wear in this pulley right here. It should be a perfectly V-shaped, and it's got grooves in it. So that's not good. But we're gonna see what happens when we put this belt on. So we've got a brand new one right here. So we loosened this up. So this bolt just loose. Same thing on the other side. And then back this nut out, and then you have this. Now here's the problem. If we look at this, it's gonna be hard for you guys to really see this, but this pulley right here is doing this. It's twisting this way. And it's simply because we've only got tension on one side, and this is bending out, okay? This whole bracket causing some problems. So if I go over here and simply push in on this, it trues up the pulley. So this is now sitting like this, crooked, not true. And then when I push this, by flexing on this side, pushing it in, it's bringing this whole thing and truing it up to where it's actually straight, and the pulley has better alignment. So we're gonna set the depth of this right here. Once we get this pushed in enough and it straightens up that, then we'll tension everything else up, if that makes sense. Now we know that this pulley is worn out, so we went ahead and got a belt on there. It's tensioned properly. We are gonna get a new pulley and another belt because we took the spare, right? So I just wrote it down right here. The outside diameter of the pulley is 3 3/4. It's adjustable. The bore or the shaft is 7/8, and we need an AX48 belt. So we put the spare on here, got it running, tensioned it up, so that way we can troubleshoot further to find out if there's any other problems, and we're gonna move on. But we shouldn't have to take that belt off. Well, actually we will when we change the pulley. But anyways, this gets us going so we can further troubleshoot. Other things that we need to pay attention to, look at this. Wires just hanging, that seems logical. Why don't we zip tie some of these up? We gotta be careful, but we should zip tie these up so they're not hanging down on the metal. Gotta be careful what you're zip tying them to also, because there's liquid lines right here. And And we don't want to zip tie to that because then it could short. So we'll figure, we might just do it to the suction line insulation real quick, just lightly zip tie it so that way they're not touching the metal. This guy's running. Oh, there is a vibration to this. There's a rough vibration. So the question is it just the bad pulley? Because I think it might be. I think the pulley is catching the belt and it's kind of getting stuck. I think, but we don't know for sure. But okay, go ahead and shut it. And then we're gonna wait. Now this guy still has an error code, active 34. Let's go ahead and reset it. Hold this down. And if it comes back, we might have to let the evaporator run for, or the evaporator fan motor run for a little bit to warm up the evaporator to possibly reset the freeze stat. The freeze stat's still activated because the evap's still cold. 32, freeze stat 1, 34, freeze stat 2. So both freeze stats are open. So that's fine. We're gonna let it run with the indoor blower motor for a few minutes. It'll warm up the evaporator. What we could do, because it's kind of cool down in the dining room, is you could simply just open this up right here. And right now the compressors aren't running, so it's drawing air in through here. It's warming up these freeze stats. These are the freeze stats right here. One thing that Lennox did really good on these older units is labeled everything. So S50 and S49. And then that way, when you see the error code, you know where the freeze stat is. And all that that's doing is looking for a frosted up coil. I opened the coil cleaning access door because I want to see why this motor's not running. The motor itself is not hot. It's cool to touch. So more than likely, it doesn't have voltage. I pulled the plug. I'm going to put the meter in it, check to see if we have voltage going to the motor. Don't think we do. That would lead us to the condenser fan motor relay or possibly the fan cycle switch. 18 volts is coming to the motor, so I don't think the relay's closing. So let's go find out if it's the fan cycle switch or what. Without getting in here and bypassing the fan cycle switch, let's just disconnect condenser fan motor number 1. Because condenser fan motor number 1, I believe, is running. I believe that's the one that's running. So if you look at our system pressures, we haven't even profiled. Compressor number 1, 172 PSI. Compressor number 2, 251. I'm assuming maybe the threshold to close the fan cycle switch is somewhere around 250, 260, 75, somewhere in there. So if we disconnect condenser fan motor number 1, which should be this one right here, if I can safely do this, okay? That motor should have shut off. Let's see. Ah, that's not condenser fan motor number 1. That's condenser fan motor number 2. That's number 1. So that's interesting. Usually 1 would shut off. Okay, I'm gonna put that back and we'll disconnect the other one and see if we can close it. Disconnected the other one, it shut off. Now we're gonna come over here. What the heck is that noise? Let's look at the pressures. 275. Maybe it just came on because it went up and then it started dropping. Yes, so fan cycle switch closes at like 270 something. So we just proved that the fan cycle switch is working. So now we can further diagnose. So what we're gonna do right now is we'll get both condenser fan motors running. Even though it's low ambient and the fan cycle switch is turning it off, we wanna see both the systems operating. They should, in theory, be running very similarly, have very similar pressures. They both have the same indoor and outdoor conditions. So in theory, if we get both those motors running, they should be pretty close to each other. Now, before we go crazy here, I'm asking you watching the videos right now, let me know in the comments, why would we be staging the condenser fan motors with a fan cycle switch right here, or a low ambient switch? Why? You know, I mean, what's the purpose of shutting down a fan motor and turning it back on? Why would we need to do that? If we come over here to the gauges, we can see it really makes perfect sense. I'm using liquid pressure. I'm not using discharge pressure. My liquid saturation temperature is 76 degrees. That is probably at the bottom of the threshold of what the condenser or the expansion valve was sized for. See, that expansion valve is sized for a certain liquid pressure. If it doesn't have that proper pressure pushing the gas through the valve, then the expansion valve becomes a really dumb paperweight. That's exactly what it is. That expansion valve opens and closes. If we look right here, we can see it. This expansion valve right here, it opens and closes based off of suction line temperature, and then it's also affected by evaporator pressure, right? But here's the thing, that valve can only operate within a certain threshold. And if the gas is not flowing through the valve at the proper flow rate, then the valve can't properly control the superheat. And that's the goal of the expansion valve, to control superheat. So if my liquid pressure is too low, or liquid saturation temperature, liquid pressure, right, is too low, then it's not feeding the gas, pushing it through that valve fast enough, and the valve, because it's a dumb expansion valve, it's not an electronic expansion valve that uses sensors, it's just a mechanical valve, it can't control the superheat properly, so it starts to lose control of the superheat, and you start seeing hunting or different things like that. You know, we need that pressure. Let's think of it like this. If you take a water hose and unrestricted, you just turn it on with no nozzle on it, that water is going to flow out at a certain rate. But if you increase the water pressure, the water is going to flow out faster. If you decrease the water pressure, the water is going to go slower, okay? Now let's think about it like this. We have to push that gas through that valve, just like the water pressure of the hose. When it's unrestricted coming out, that valve is only designed to have that gas going through the valve at that set rate. And anything outside of the operating envelope, whether it's too high or too low, more or less too low, can start to affect things. So that's why we cycle the condenser fan motors, because right now, our head pressure and liquid saturation temperature is right at the border of being too low. But this air conditioner still needs to be able to operate within the proper, or it still needs to be able to cool the building no matter what the temperatures are outside. So that's why they put low ambient fan cycle switches on these liquid lines. They look at the liquid pressure and it stages the condenser fan motors based off of the liquid pressure. Okay, so right now we're borderline right at the bottom end because it's kind of cool outside. So that's why we're staging these fan motors, okay? Now we need to figure out, is the system operating properly? That's what we need to dig into further right now. Before we go any further, we went and picked up a new motor pulley. So we're gonna go ahead and we shut off the unit. We're gonna go ahead and get the motor pulley changed out first, because that can in theory affect the airflow, which in theory would affect the operation of the unit. So we're gonna get this pulley changed out real quick. All we're gonna do is loosen up the set screw. It's a new-ish motor, so it shouldn't be too difficult, famous last words, to pop off of here. And then we've got a new pulley right here that we're gonna get set to the opening of this one. Now this is a perfect example. This isn't the ideal pulley that I would wanna use. This is what the supply house had, so we're gonna use it. But look at how thin the walls are right here. Look at how thin that is. And let's look at this one. Look at how much thicker these ones are. So these ones are gonna be more likely to probably wear out faster. Notice how thin it is as opposed to this. See the thickness difference? Another thing is you can't always, well, actually, no, I don't know where I was gonna go with that. But anyways, it's functional, it'll work. We're gonna get it put on there, but we gotta pay attention to the inside diameter and how far that belt is riding in there. We need to try to match this pulley to match that same opening, so that way the belt sits in there, because this right here is how we adjust the airflow on this unit, this pulley. We do not use the pulley to adjust tension. We use the tensioning components. This right here, opened or closed, is gonna slow down how fast this motor drives the blower assembly. Got the old pulley off right here. We got the new pulley already on, and we pulled out the set screw because you gotta make sure that set screw is hitting the key, and it is. It's dead on with the key. The pulley's about as aligned as it should be. We might need to adjust the tension just a little bit tighter, but we're pretty good right here. So we're gonna go ahead and get this pulley tightened on, and then further diagnose to see if the vibration goes away, and then we'll finish diagnosing the refrigeration circuit. Since we changed the motor pulley, which can change the speed that the motor drives the blower assembly, we need to make sure, now we matched it up to the other opening, but we need to make sure that the motor is not over amping now. So we have our FLA amps. We need to make sure with this door closed that this motor doesn't amp over 8.1 amps, okay? That is the lower of the two voltages this motor can run at. So we need to write it down 8.1 amps. I verified the wires. I just kind of tugged on them. You can see I'm tugging right here. This is my indoor blower motor contactor. So I should be able to grab any one of these wires and make sure it's not running over 8.1 amps, because we don't want to overload that motor. Very important too, this door needs to be shut. because with the door open, it's got unrestricted airflow. It's going to overamp. It's going to show a different reading than when if you actually load it up and shut the door, put it under a true static pressure. That's the way it's going to operate all the time. So we want that door shut. All right, this guy started up with the door shut. We're running 4.7 amps. The vibration has gotten a little bit better, but it still has something going on there. It's not going to be in the motor more than likely. It's going to be in the bearings and the blower assembly, but it's not, I don't think it's as bad as it was. Okay, so we'll leave that open. Look at this. 5 amps. Go ahead and shut the door. 4.7 amps, because it has true static across that unit now. All right. So vibration's better, but it still has something going on. But this is a really old AC too, so I don't know how far they want to go with this. But we know that we've got a new pulley on there. We're not overamping the motor. We can fully diagnose this unit now. We'll go ahead and let it go back into cool, and then we'll check all the stages and see how it's operating as best, the refrigeration circuit is operating essentially. All right, first stage, we're running a 34 degree suction saturation and an 80 degree liquid saturation temperature. This is R22. Metering device is an expansion valve. We've got about 6 degrees of subcooling, 10 degrees of superheat. What I'm noticing though is the first stage, the superheat is really bouncing all over the place. We have a lower saturation temperature and a lower subcooling than the second stage. Let's go ahead and switch over to the second stage. Our liquid saturation temperature went up to 90 degrees. Suction's doing about the same because the expansion valve's doing what it can to control the second stage. Let's give it a second. 16 degrees subcooling is not accurate on this. It is, but let's give watch, the subcooling will change actually. So we're running higher pressures, higher subcooling, normal superheat on the second stage, as opposed to switching over to the first stage. We've got a lower subcooling. Superheat is kind of calming down right now, but it's bouncing around. But we're running a lower a liquid saturation temperature. To me, it kind of indicates that we might be slightly low on refrigerant on the first stage. Is my guess on this. Now the question is airflow. Now airflow on this app is not always very accurate. We're looking for about 3,000 CFMs. This is an estimation. I don't really think we got an airflow problem. We do need to go down and look at our return air grills, make sure they're not dirty. But a few minutes ago, the airflow was saying it was smooth and good. Now it's saying it's wonky. But we'll give it a little bit more time, but I have a feeling that we're gonna need to do a leak search on that first stage and maybe add a little bit of refrigerant to get it to operate a little bit better within the existing airflow that we have in the building. All right, this is R22. You can charge it as a vapor or liquid. Now we are gonna charge it as a liquid, but for purging purposes, instead of wasting a bunch of liquid, we're just gonna push a little vapor through here. So I put my hoses on, right here. Just a little vapor. We're clearing the line out. And then we're gonna close it and leave it slightly cracked. Put it on the system with it slightly cracked. That way we know we're not introducing contaminants to the best of our ability to the system, right? So then now we can flip this over, of which I wrote downstairs the drum weighed 14 pounds. So we know when we're done, if it's anything less than 14 pounds, which it will be, that's what the customer gets charged for, okay? So we make sure everything's tight. Down here. Tight. Now we control the flow of refrigerant through this valve right here. We can open and close it, dumping it into the low side a little bit at a time while we're operating our system, and we can get it charged up to where we think it needs to be. We're gonna aim for pretty close to 10 degrees subcooling is what we're gonna aim for on this while we're watching everything else. We're looking pretty good. We just added a little bit of refrigerant on the first stage. Things are still moving around a little bit. As the expansion valve opens and closes, finds its happy place, calms down, subcooling's gonna kind of dance around, but we're just watching it, adding a little bit at a time. We got our liquid saturation temperature up. Unit seems to be working. We'll go to the second stage. You can see in comparison, second stage is consistently running at about 10 degrees subcooling. Superheat, I've seen it range from 8 to 12 degrees, so it's kind of bouncing around. Temperature split across the unit's about 24 degrees. I don't understand what is going on with airflow on this. It uses like an estimation algorithm in this, and I just don't know what to say about it, because on these 2-stage units I tend to have a hard time. I know it needs to be on 2-stage when you're looking at the airflow number, because if you go to 1st stage, watch, it'll change. Let's see if it changes. 2266, and then if we switch over to, see, 2093, it uses some sort of backwards calculation with mass flow and I don't know, some weird stuff. But I don't really think we have much of an airflow problem. I mean, clearly we have something, but I don't think it's any different than normal, because you typically don't want a 24-degree temp split on these things. Delivered capacity seems low, but I think the airflow is just, something's wonky with that. Maybe it's where the probe placement is or something. But with the existing airflow, this unit, we'll give it a few minutes, let everything stabilize out, make sure we don't, yeah, see, everything seems to be kind of where it should be. This guy, I think, is doing everything it can. You know, probe placement is a big deal on these, and when you're working on package units, unless you're going all the way downstairs, that's not accurate. Having the supply probe that close to the evaporator, it really should be down at the first supply diffuser so it can accurately measure the air being delivered into the space. Right now, it might be colder because there might be heat gains as it goes through the ductwork or something. Then it's not reflected in the, or it is reflected in the return, like things go out of whack. But sometimes you got to deal with what you got to deal with on a package unit. It is what it is. So understand, not everything's going to be perfect. Plus these units are old, but this thing's looking pretty darn good. Superheat and subcooling are kind of bouncing around a little bit. We're within line. Added a little refrigerant. We're still going to do a leak search on this guy. We were just downstairs looking at all the returns to make sure nothing crazy is going on down there. We'll watch it a little bit longer, but I'm not seeing anything scary. These compressors keep making the sound. This one, the 1st stage. Do you hear that? Every once in a while. There it is again. Which one's that? Every once in a while, this thing's making a... That's interesting. It keeps making like a weird sound. This customer needs to consider some equipment upgrades, because I suspect we got a compressor going out too. It's doing some weird stuff. Superheat's not too low in that right now, and it's making that weird sound. The other thing we haven't checked is our contactors to make sure we've got no voltage drop across them too. So we're definitely going to look into that. But what we did right now was we unplugged, because I had bypassed the condenser fan motor to run all the time. But I want the fan cycle switch put back in the circuit so that way we can actually see it turn on by itself. So right now head pressure is going up because the fan motor is not off. So we're not looking at the subcooling and superheat now because we're fluctuating. Something I wanted to say is you can't have these fans staging on and off when you're diagnosing this. That's why I jumped them out and had all the fans running. You don't want them turning on and off, because everything's going to be affected when these fans turn on and off. Fan cycling, in my opinion, is not a great way to maintain head pressure, but on a unit like this, it functions and it works. Head pressure control valves do much better, but obviously you need a lot of extra refrigerant for a head pressure control valve, so you'd need a receiver, and they don't do that on package units for the most part. Our condenser fan motors are both running now, so we know that the fan cycle switch is working, and my head pressure dropped. It was in the 220-ish range, and now we're at 170. So that's normal. The fan cycle switch is working. We've proved that. Now we're just going to do some other maintenance. We're going to inspect the contactors, take off all the probes, and then we got to do a leak search on this guy. We look at the indoor blower contactor, and the points don't look too bad. That's the point right here at which, when this closes, it makes a connection. You typically are going to see worse on the compressors because the compressors stage throughout the day. So this contactor, if everything is working right, is only going to turn on and off once a day when it goes into occupied mode. And then it's going to run all day long. But these, multiple times an hour, are going to turn on and off, on and off. So you tend to see these ones get burnt before these ones do. So now we got these ones off. And you're going to see these ones are, if I can get it to zoom in, are a lot more burnt. Kind of hard to see, but you can see they're definitely a little charred. But I mean, honestly, maybe on this one Let me look at the other one. I need to get without the camera and check these out. We may or may not change these. The contactors are not the worst, but they're definitely not the best, and they're pitted. But here's the thing. We're not getting a voltage drop across them. So, you know, people in the comments will say, why would you change that? It didn't have a voltage drop. You wasted the customer's money. Well, here's the thing. You don't have a voltage drop until you do. And when you do, the compressor suffers. So why wait until the moment that you actually measure a voltage drop? Are you gonna be here every day to measure this, to monitor this contactor every day? Or does the customer call you to do routine maintenances 2-3 times a year and service calls whenever it breaks? Well, if that's the case, if we change these contactors now, they are burnt, they're not horrible, but they're burnt. We don't know when it's gonna go bad. And when it does go bad, how well are these old compressors gonna stand low voltage? Are they gonna become a problem or not? A contactor is a pretty cheap item in comparison to a compressor replacement. Compressor replacements are very expensive. Now, granted, this one was making a weird sound. More than likely something's been changed here, because you see how one has a Molex. This compressor has been replaced before, because notice you see the compressor circuit 2 stuff here, but you don't see it on this one. This one is dated 03. This one is dated 06. So this compressor was changed 3 years-ish after startup. But this thing is sounding a little bit rough, but does it have anything to do with the contactors? I don't know. But those things are cheap insurance to protect the compressor and make them last longer. Now, yes, we still haven't found a leak in this thing. This thing more than likely has a leak somewhere. The customer needs to replace it, definitely. There's no doubt about that. But they also need a functioning air conditioner. This customer, I know them, they do not want an air conditioner to go down, even if they got to spend some money while they're ordering a new one. They want it operating, because if guests don't want to sit over there, they're not selling food, they're not selling alcohol, they're not making money. So throwing some contactors on this and some refrigerant in it to get it going is worth it to them, to keep their units functioning until they can replace it. Let's see, we weighed 14 pounds when I took the refrigerant up there. So we're gonna call it, we'll just call that 12. So we'll charge them for 2 pounds of refrigerant. And then I'm gonna grab some contactors, and we're gonna get those 2 contactors changed out now. Coil voltage is coming in on the bottom of these contactors, so we need to rotate the cover plate around and rotate the base plate around. So I'm gonna do that real quick. These screws, rotate it. You do have to clip the little portion of the contactor up here to get it to fit. We're gonna get them both flipped around so that way the writing is right side up, because they need to mount like that to get the coil voltage in the top, and that drives me nuts having the writing upside down. You could, I guess in theory, pull the sticker off and reapply the sticker if you wanted to too, but I just switched the covers. We're gonna swap these out. I wrote on all the wires, even though it's color to color, I still put a hash mark, 1, 2, 3, 1, 2, 3. Even on the wires back, 1, 1, 2, and then the back 2, those are coil voltage. Same thing on this, 1, 2, 3, 1, 1, 2. But always take a picture too. We should be able to pop these in there, pop the other ones out, or vice versa, whatever. So I pulled the points out of one of the old contactors, and you can see they're not the worst I've seen, but they're also not the best I've seen. Sorry, this unit's shaking because it's a make-a-bear unit. But you can see that, yeah, those points, they should be shiny silver, typically coated with silver on the outside, or some metal that's conductive, but you can see the burning and the pitting. So at what point does that become a problem is the question. I don't feel comfortable. I'm doing a repair on it. I'm gonna go ahead and replace them. That way they're, you know, not part of the equation anymore. We got into both sides, leak checked the condenser, didn't find anything, got in here, leak checked in here, found nothing, got in here, leak checked the evaporator, found nothing. So this guy's clearly got a small leak somewhere, but it's not jumping out at me right now. I put in 2 pounds of the 9-pound charge. I mean, it's a significant amount, but it's hard to say. I'm not seeing anything right now, so we're not gonna go too much further with this. We'll just tell the customer to keep an eye on it. And again, I'm strongly recommending they consider replacing this unit as it's getting older and older, and R22 is getting more expensive and more expensive, right? So we did our best. We found a broken belt. The cause more than likely was a bad motor pulley. We replaced that because it was worn out. Further diagnosis, found the unit was a little low in refrigerant. We didn't find any leaks. We topped off the charge, changed 2 contactors that were worn out, and this unit's doing everything it can. We did look at the return air grills. They're a little dusty. They could certainly be cleaned, but I don't think they're affecting airflow very much. We'll bring that to the customer's attention. I'd really like them to consider replacing this unit as it's time. I mean, 03 is when this unit's from, and we're in 2026. So they've gotten their life out of this unit, and it's time to really consider replacement. So we will talk to them about that. But until then, this unit is operating as best as I can get it right now. I mean, everything's doing what it can and doing what it should be doing. So I appreciate you guys making it to the end. Thanks so much. We try our best with these customers. We're not perfect in no way, but we try to, you know, make sure that what we are doing as far as repairs gives them the best bang for the money that they're spending, kind of a thing, you know. But again, thanks so much for making it to the end. If you haven't already, please consider subscribing to the YouTube channel. You know, there's a couple different ways to support this channel if you're interested in doing so, but the easiest way is just watch these videos from beginning to end like you're doing right now. But you can also support it via PayPal, Patreon, YouTube channel memberships. You can go to my website, hvacrvideos.com. We have merchandise available, hats, great way to help support the channel. Last but not least, you can go over to truetechtools.com. If you see any tools like the Fieldpiece SC480 meter, you didn't see me using it, but the Fieldpiece DR82, that's the leak detector I use. I picked all that stuff up from True Tech Tools. I have an affiliate program set up with them. So if you buy anything and you use my affiliate code, which is Big Picture, that's one word, okay, Big Picture, you get a nice discount on majority of the items, and I get a small commission every time you make that purchase. So great way to help support the channel. Again, thank you so very much. Leave me some feedback down in the comments. Tell me what you have to think about the repair and everything. And I hope to catch you on the next one.